Hello everyone, it's Mr. Grant here. Today we'll be looking at a pretty common problem that you see in general chemistry courses called titration problems. Titration is a common technique used in chemistry to determine the concentration of a solution by reacting it with a solution of known concentration until the reactants are completely used up. It can be used in many different industrial applications, but the most common type of problem involving titrations for students is acid-base titrations. So today we'll look at a simple way to solve any titration problem in just a few steps. So let's look at this example where X moles of A react with Y moles of B to produce some products. Firstly, I want to reiterate that the core to understanding any titration reaction is recognizing that my given moles of Y react exactly with my added moles of B, such that there are no leftover reactants. So this could only happen if the moles of A and B are present in their stoichiometric ratios. In other words, the ratio of A to B must equal the ratio of their coefficients from our equation, which is X to Y in this case. It's also important to remember that moles of a solute in a solution is equal to the concentration of the solution times the volume of the solution. So combining these two equations yields this expression, CAVA over CBVB equals X over Y. Pause the video if you want to make note of it before we move on to our example. To use it, we'll need to know at least 3 of the 4 variables listed in yellow, which are the concentrations and volumes of our 2 reactants. All right, here we have an example problem. 25 milliliters of calcium hydroxide is titrated with 49.2 milliliters of 1 molar hydrochloric acid. Determine the concentration of calcium hydroxide. So in this example problem, we are given the volume and concentration of the acid along with the volume of the base, and we're asked to find the concentration of the base. So let's start by writing a balanced reaction equation. Okay, hydroxides react with acids to produce water and a salt. In this case, our reaction is unbalanced. We'll need to add coefficients of 2 onto the acid and the water to balance the expression. I'll label HCl, our acid, A, and I'll label our base, calcium hydroxide, B. So now we can set up our mole ratio. The number of moles of A present will be the concentration of A times the volume of A. In the denominator, we use a similar expression but with the values given for B. We can set this equal to 2 over 1, which is the stoichiometric ratio for A to B from the balanced reaction equation. Okay, knowing that this ratio must equal 2 to 1, we can plug in our given numbers, such as 25 milliliters for the volume of B, 49 milliliters for the volume of A, and 1 molar for the concentration of HCl. Note that I left volumes in milliliters, and this is fine because their units will cancel out anyway, being that both the numerator and denominator have milliliters present. Okay. Lastly, I can solve this expression with a little bit of algebra. In this case, the concentration of B, our calcium hydroxide, comes out to be 0.324 molar. Again, I want to mention this method works for any titration problem, no matter how complicated the reaction. So good luck, and let me know if you have any questions in the comments below. Have a good one.